Quartic graphs. We have seen that quadratic graphs have a single turning point, either a maximum or a minimum. So this one has a maximum and this one has a minimum. We have seen that cubic graphs can have two turning points. So they may look like this. It may go the other way. Or a horizontal point of inflection. So something like this, where it goes flat at one point. We can view a horizontal point of inflection as being a maximum and minimum being coincident. In other words, at the same point. Now I think I can demonstrate this using Desmos graphing calculator. So here I have a cubic, and we can see that we have a maximum here and a minimum here. And by changing the value of b, I can move those closer together. And you see that as we do that, it gradually becomes a horizontal point of inflection. If we view it that way, then quadratics have one turning point, cubics will have two turning points. It follows that quartic should have three turning points. But remember, these two turning points may happen at the same place, in which case we end up with a point of inflection. This will make more sense when you cover differentiation if you haven't covered it already. So what implications does this have for the shape of quartic curves? Well, they may be shaped like this. That's just one turning point, but we can view that as three coincident turning points, three turning points that all happen in the same place. We might get a turning point, either a maximum or a minimum, and a horizontal point of inflection somewhere else. So we've got one turning point and one horizontal point of inflection. So that's one turning point and two coincident turning points that lead to the point of inflection, just as it did with the cubic. But we could also get something like this, or like this. And that's just three turning points, which are all distinct.